Welcome to Khetztutorials, and in this video I will be doing examples, and these examples are under trigonometry. So trig examples. So to start with, I have a diagram, so let's just call this question 1 if we must, right? So this is question 1, and we have a diagram which looks something like this. If we could just draw a straight line over there. So these are axes that we have with us. So we have X and we have Y over there. Then you have a line from the origin to a point, let's call it P, over there. And it has coordinates X 24. And we're told that the OP, or the length of OP, is 25 units. Right? So the first question, so let's call it 1.1, is asking for the value of X. So told that this is 25, and we know that we have a formula which says x squared plus y squared is equal to r squared. That is due to the Pythagoras Theorem, and therefore we can therefore find the value of x because we know y from there, and we know our r, which is from the length of OP. And therefore, we can say that x squared is equal to r squared subtract y squared, which means that x is equal to the square root of r squared subtract y squared. And substituting actual values into that will give us 25 squared subtract our y of 24. And the answer that we expect for the value of x is 7. So x should be 7. That is your answer for the first question. Now, in the question that follows, we are asked to find the trig ratios. So let's just put it maybe up here. Let's just erase to create some space so that we work closer to the diagram. So that is the first part. Now the second part is asking us to find each of the trig ratios. And so we are asked to find cosine of theta, and theta is indicated over there. We are asked to find sine of theta, and we also asked to find tan of theta. Now, if you look, or if you remember from the previous videos, your cosine of theta is x divided by r, your sine of theta is y divided by r, and your tan is y divided by x, right? And therefore, we expect to have a cosine of theta of x, which you just found in the previous question, divided by our r of 25. We expect our sine of theta to be equal to the y 24 divided by r of 25. We expect y divided by x, which is tan theta, to be equal to 24 divided by the x of 7. So that is how you'd answer such a question. So basically, just look at the diagram and just substitute your x, y, and r values into the appropriate trig function. So another question which stems from that would be 1.2.2. That's what we're going to call it. And it's asking us to find tan of 180 degrees subtract theta. And we can use the reduction formula. If you remember the video on reduction formulas, we can use the reduction formula. If you look at the cast diagram and we look at 180 degrees, so 180 degrees, then we subtract theta. We land in this second quadrant, and tan is negative in that quadrant, which means we have negative tan theta. And we know that tan theta is equal to 24 divided by 7, and therefore negative of that would be negative 24 divided by 7, and that should be your answer. Now the final question with regards to this diagram is asking us to find the value of theta. So how can we do that? We basically just take any of the trig functions which we have with us over here and do the arc of those. So basically, let's take the first one, for instance. So cosine of theta is equal to 7 divided by 25. And therefore, your theta will be equal to the arc of cosine and you should get a value of 73.74 degrees as your answer. So that is basically all that you have to do, or that you have to know, with regards to such a diagram where you're given a point, you're given coordinates, you're given the length of the radius, and you're asked to find any of these values. So you saw how we tackled this using reduction formulas. You saw how we calculated one of the values, x in our case, and how we applied that to find the trig functions. So we are just going to move along to another example on the trigonometry, but this one deals with identities. So let's talk about identities now. So you should know all your identities, and we are asked to simplify the following. To simplify, the first question is as follows. We have cosine squared 45 degrees divided by sine of 30 degrees, and that is multiplied by cosine of 0 degrees and divided by tan of 60 degrees, right? So asked to simplify this, and we can use reduction, special angles, anything that you can basically think of, right? So whatever comes to your mind first, use that. Right? So in this case, we have cosine squared, and to simplify that, what can we do? We basically just check and say that we actually have a special angle of cosine of 45. So you just basically square that, and if you go back to the diagram, and so this diagram will be quite useful, just draw it whenever you have such questions, and it will be helpful to you to actually have it near you, right? So if you remember this diagram, and then you put the square root across everything, square root, square root, square root, square root, square root, and square root. So these are the coordinates which are associated with each of the angles: 30 degrees, 45 degrees, from there to there, and finally 60 degrees over there. So now we have cosine of 45, which falls here, and cosine is x divided by r, and we know that our r is equal to 2 in the case of special angles. So we're going to have square root of 2 divided by 2, which is our r, and then we're going to square that. And then we're going to find our sine of 30, which falls here, and the sine is y divided by r. So the y value over there is square root of 1, which is basically just 1. And now that we have that divided by r, which is 2 in the case of special angles. And now cosine of 0, if you come to this point over here, it's x divided by r. So x is basically 2, square root of 4 is 2 divided by the r, which is 2 as well. Then you have 1 over there. So you have 1. Then you have your tan of 60, which comes here, which is y divided by x, which is square root of 3 divided by 1. And the answer to that is square root of 3. So now in the process of actually simplifying everything, and we only used special angles which are known to us, and applying those special angles, we basically say that we square this part, the top part, and we're going to have 1. We're going to have 2 actually. Before simplifying, we're going to have 2 divided by 4, which is the same as a half, and we have a half at the bottom, so that cancels out with that, and we're only left with 1 divided by square root of 3, and that should be your answer. That should be your answer. So the answer to this is 1 divided by square root of 3. If you are required to change its form, you can just multiply the top and the bottom by square root of 3, and you should get square root of 3 divided by 3, and this is basically the same thing, right? And that is your answer for that question, where we asked to simplify this equation, or that, whatever you want to call it. So now we come to a second one, which is also asking us to simplify. So let's say you're given this and you're asked to simplify it, given the following. You're given negative 330 degrees, given sine of 480 degrees, and you're given the sine of 260 degrees, and you have a denominator which has cosine of 225 degrees. Then you have sine of 315 degrees. Then you have cosine of 350 degrees. Now, whenever you see these funny looking angles, just basically relate them to the nearest angle, or just see how much you can add or subtract to the nearest angle, right? So, for example, if you have negative, here you have negative 330, you'll notice that from negative 360, you can just add 30 degrees, right? And here you have 480, you notice that from 360, you basically add 120 degrees. And here you'll notice that you have the next one is 260. So from 180 degrees, you have 80 degrees more. So basically just use the ones which you can form reference with, and that is going to help you to apply your reduction formulas. So now we have at the bottom, you have cos 225, which is 45 degrees greater than 180. Then here you have 315, which is basically 45 degrees less than 360. And at the bottom, you basically just have your, what do you have? You have this cosine here, which is 10 degrees less than your 360. And yeah, it's 10 degrees less than 360. So that's what we have so far. And to proceed, we're just going to do or apply the reduction formulas. And to correctly do that, we're going to have, if you look at the CAS diagram, so this is another diagram which you should always have in mind or on your paper or wherever you're working. So if you look at negative 360, then you add 30 degrees. Then you're going to end up in this first quadrant, which is the quadrant where all of your trig functions are basically positive. So the result of that would lead us to a tangent or turn of only 30 because it's positive in that first quadrant. And if you look at 360 degrees, that is for your next one, which is your sine. If you look at 360 degrees and you add 120 degrees to that, you basically expect your function to fall in this quadrant, which is the second quadrant, and that is where your sine is actually, it is positive, right? Now you'll notice that this is a double angle of 60. So sine 120 is the same as sine 2 multiplied by 60 degrees, right? And we can transform that to 2 sine 60 degrees multiplied by, what can we multiply? Okay, let's multiply by that. And to find this, we can basically use the special angles to find each of those values. And that is what we're going to do in a bit. And here, if you look at 180 degrees and you're basically going to add 80 degrees, you fall in the tan quadrant, and that is why you're going to have negative sine of 80 degrees. At the bottom, you're going to have 180 degrees, then you're going to add 45 degrees to that, which leads you to the third quadrant, and cosine is negative in that quadrant. If you look at 360 degrees and you subtract 45 degrees, you're going to land in the fourth quadrant where your sine is essentially negative, and you're going to have negative sine 45 degrees. And in your cosine 360, then you're going to subtract 10 degrees, you have a positive cosine, and you're going to have positive cosine 10 degrees. So that is what we have so far, and we can basically find the values of some of these using special angles. And so let's do that quickly. So tan of 30 degrees, if you come back to your diagram, which I drew in the previous question, so tan of 30 degrees, which should be over here, is your y divided by x. So 1 divided by square root of 3. That is what that is. So 1 divided by square root of 3 is what I expect over there. So 1 divided by, we can just draw the diagram again, but it doesn't really matter. So 1 divided by square root of 3. Then you have multiply by 2, which is from there. Then you have sine 60. Your sine 60, you can just come to the diagram again and look at the 60 degree and say y, which is square root of 3 divided by 2. So square root of 3 divided by 2. And your cosine of 60 using the same point, 60 degrees, will be 1 divided by 2. Right? So that is how you basically use that diagram. You're going to have half for that. Then you're going to have your negative sine 80 degrees. Then at the bottom, you're going to have negative 45 cosine of 45, which is going to lead you to, so your negative cos 45 is going to lead you to negative square root of 2 divided by 2. Then you're going to have the same thing here, negative that, right? Then for this part, which is cosine of 10, you can just transform this into a sine of, so this is the same as having sine 90 degrees subtract 10 degrees, right? And the result of this, so I'm basically using co-ratios. If you have sine of 90 degrees subtract a certain angle, it's equals to a cosine of that same angle. So in our case, we have 10 degrees. So I transform this cosine of 10 degrees into sine of 90 degrees subtract 10 degrees. That is what I basically have over there. And if you just simplify what we have already, you can cancel that, cancel that, cancel that, cancel that. At the top, we have a half. And we are basically going to multiply the negatives over there, this negative and that negative. It's going to be positive. Then multiplying square root of 2 by square root of 2, it's going to give you 2. And then multiplying 2 and 2 at the bottom is going to give you 4. So that is basically 1, because that is half divided by half. And then you have your negative sine 80 degrees. Then you're going to divide that by sine of 80 degrees. So these two cancel out, and not forgetting the negative sign over there, and therefore your answer to this is negative 1. So basically just use the reduction formulas to reduce most of these, and then we use special angles to find the exact values. But for those which we couldn't find exact values, we just used co-ratios there, and they actually canceled out. So that is the kind of stuff you should look out for when you're trying to simplify equations. And we're going to move along to the next example, and the next example is associated with equations, right? It's associated with equations, and we're actually going to solve equations, right? So we are asked to determine x if 2 sine x subtract 1 divided by sine x is equals to 0, and we're given the following limits that x is between 0 degrees and 360 degrees inclusive. These are the restrictions that we're given, and we're asked to solve the given equation at the top, right? So now that we have that and we have to solve that, we can go ahead and do our general solution, right? So doing the general solution, we're gonna write our equation again and say 2 sine x subtract 1 divided by sine x is equal to 0. Then we're going to multiply through by sine x, and the result of that will be 2 sine squared x subtract 1 is equal to 0. Then we're going to equate 2 sine squared x is equals to 1, right? Then I'm going to divide both sides by 2. Then you're going to have a half. So sine squared x is equals to a half. So that is what we're basically going to have over there. And therefore, doing the square root of both sides, we're going to have plus or minus 1 square root of 2, right? And the answer to this should be, so if we do the reference angle, so if we do the arc sine of this, we're basically going to have, so the positive one is going to lead us to 45, and the negative one is going to lead us to negative 45. So now when we do our general solution, we're going to say x is equals to 45 degrees plus 360 degrees multiplied by k, where k is an integer, or x is equals to 180 degrees subtract 45. 45 degrees plus 360 degrees, k is an element of all integers. And now on this side, we're also going to have the or, which covers the negative side. And that's going to say x is equals to negative 45 degrees plus 360 degrees k, where k is an element of all integers, or x is equal to 180 degrees subtract that negative 45 degrees plus 360 degrees multiplied by k is an element of z. Okay, so now that we have that, we can basically simplify everything, and here you'll see that we have a value of, if we simplify this, we basically just subtract that. We basically just have 135 degrees over there, and if we come to this point here, we have the addition of these two, which is going to lead us to 225 degrees. Now let's check. In the question, we can't just leave all of these as our answers, because in the question we're given a restriction that our x should fall between 0 and 360 inclusive, right? So now that we're given that restriction, we know for sure that we have to restrict our solutions as well. So if you now finalize your solution, you only have to list the solutions which occur in between 0 and 360. So the first one would be 45, right? First one would be 45, and another one would be 135, of course, and another one would be, so you can just do this instead, just list them like this. And another one would be 225, and if you come, let's say here, and substitute 1 over there, so you're going to have 360 degrees subtract 45. After substituting the integer 1 for k, basically going to have 315 degrees. And that is going to be one of your answers. Now, if you look for any other solution, you'll see that if you were to substitute -1 here, you'd be going in the negative range, which is wrong. If you were to substitute 0 here, you'd have 45, which is already in our solution. If you were to substitute 1 here, it would be greater than 360, which is wrong. Moving on to this one here, if you were to substitute -1 at this point, you'd basically be going in the negative range, which is wrong. If you substitute 0, you have 135, which is already in our solution list. If you were to substitute 1, you basically have an answer which is greater than 360, which is wrong. So we stop again. If you come here and you substitute -1, you basically have a negative answer, which is wrong. If you substitute 0, you basically have -45, which is in the negative range as well, which is wrong. If you were to substitute 1, you'd have 315, which is already in our solution list. Now for this last one, if you were to substitute -1, you'd be going in the negative range, which is wrong. If you were to substitute 0, you have 225, which is in our solution list. If you were to substitute 1, then you actually be going greater than 360, which is wrong. So the only solutions that apply for this particular problem are the following ones. So you should always check your solutions when you're given a range or a restriction. That is what I basically wanted to show you in this example that you should always check your solutions and make sure that they are in keeping with all of the restrictions which are given to you in the question. So I'm going to do a few more examples, and these are just to prove or just to do some few things that you, or to apply that a few things that I talked about in the previous videos, or a few things which I expect you to know, right? So we're asked to prove that this is equal to that. So we're going to take the left hand side. Taking this left hand side, we know that tan x is equal to sine x divided by cosine x. That is just another identity which you should know. So we're going to substitute that into our left hand side. Then we're going to add everything that we see on our left hand side. And the addition of the left hand side is going to lead us to a common denominator of cosine x multiplied by 1 plus sine x. And after doing some cross multiplication or just applying what we have to apply, you're basically going to have sine x multiplied by 1 plus sine x plus cosine x multiplied by cosine x. Now that we have that, right? Now that we have that, you basically can multiply through excuse me, you can multiply through and say sine x plus sine squared x plus cosine squared x. Then say that you basically have cosine x. Let's just leave the denominator as it is. That is not what the denominator is. Right, so sine x. Right, so we're basically going to say that we have at the top, if you look at this, we have sine x squared and cos x squared, which is going to lead you to 1. That is another identity which says sine squared x plus cosine squared x is equal to 1. So this leads us to 1. So at the top, we're basically going to have 1 plus sine x. So we're going to have 1 plus sine x divided by cosine x multiplied by 1 plus sine x. Then I'm going to basically just cancel those two out, and that is going to be equal to 1 divided by cosine 1 divided by cosine of x. Okay. So now, if we look at our result, it's actually equal to the right hand side, which means left hand side is equal to right hand side, and therefore we've proven that whatever we had on the left hand side is equal to whatever we had on our right hand side. Now I'm going to do the final problem, which is quite similar in the sense that we have to prove that the left hand side is equal to the right hand side. And you really have to know this just so you quickly apply whatever you know. Or okay, so let me just do another type of problem. And this type of problem shows that, so it basically asks for which values of theta is the identity undefined. That is what you asked. My battery is running low, so let me be quick with this. So given 1 subtract cosine of theta divided by sine theta is equal to sine theta, right? 1 plus cosine of theta. I'm basically just going to give this to you as homework. It is asking for which values of theta. So which values of theta in this range 0 to 360 is the identity undefined. So you basically just have to check the values where your denominators are equals to 0. So you're going to equate your sine theta equals to 0, right? And you're going to see where that particular denominator is equals to 0. You're also going to equate this to 0. And then after that, you're basically just going to find your general solutions. Then you're going to restrict your general solutions to fall within the range of the 0 to 360 as given in the question, and you'd find that the answers to that would be 0, 180, and 360 degrees. So that is homework to you, to actually solve these general solutions and ultimately find the answers using the restrictions. That is all from me. I will see you guys in the next video. If you haven't subscribed, please subscribe. If you like this video, just go ahead and give it a thumbs up.